So now we're going to look at that question 7 of June 18 paper 1. So first of all, don't be scared by that notation. All it means is that k is a positive integer. So z is just your integers, and then plus just means it's a positive integer. So it says show that when you integrate 2 over 3x minus k with limits 3k and k, it's independent of k. So that basically means that k isn't in there at all when we integrate it. And then show the other integration gives us something that's inverse proportional k, so we're going to want something with 1 over k in it. So let's integrate. Let's have a go at integrating. Let's do the first one. Let's do part A. So I have 3k, k, and I have 2 over 3x minus k. So straight away I'm thinking reverse chain rule here because I've got my 3x there. If I think about differentiating that, that's just going to give me a 3, so the x term disappears, and then the k is going to disappear as well. So I'm thinking we can use reverse chain rule here. So when we're thinking about reverse chain, we're thinking of function of a function. So it's 1 over a function. So when we integrate that, that will just become natural log of that function. So I'm going to try f of x is the natural log of 3x minus k. So I'm going to try that, and then we can use chain rule to check that that is correct. I don't think it will be because we've got a 2 there and we don't have it in the other thing. So we know that when we integrate the natural log, it just becomes 1 over, differentiate even, it becomes 1 over that, and then we have to multiply it by the bit within the function differentiated, so that will become a 3, won't it, because the k will disappear. So here I have 3 over 3x minus k. I should have 2. So what I'm going to have to do there, if we remember, we need to know what needs to change. So I'm going to have to times by a 2 and divide by a 3. So I need to do the same thing here. I would have to times by 2 and divide by 3. So when I fully integrate that, that is going to be equal to, so f of x will be, and I'll put my limits in there, so it will be 2/3 the natural log of 3x minus k, and that will be with limits 3k and k. So now let's just put those limits in there. In fact, I'm going to put that 2/3 on the outside because I don't need it there. If you've got a constant term like that on the out, just bung it on the outside like that. Then you can deal with it afterwards. So let's put that in. And that's not a negative. So let's just make sure there's no confusion there. So we end up with 2/3 here. And then we're going to, with ln, so 3x, that would give us 9k. Sorry, 3x times by 3k. Putting the 3k in for x, that gives us 9k. So that would be the natural log of 9k minus k, so that'll give me an 8k there. And then minus, so 3x times by k, that'd be 3k minus k, so that would be the log of 2k, like so. So we're going to end up with that. And then we can rewrite that. We can rewrite logs if we remember our laws of logs. If it's subtraction, we can write that as a division. So that will become 2/3, and then that will be the natural log of 8k over 2k. Like so, we can rewrite it like that. And then the k's are going to cancel out, and then we end up with log of 8 over 2. So that'll just be the natural log of 4. So when we integrate that, we get 2/3 the natural log of 4. So we can see that's independent of k because there's no k in it. So we can, so when it's a show that, I would make it explicitly clear. So independent of k, as we're going to say that, I'm just going to be really explicit and just say that when I integrate that with those limits, 3x minus k, it equals that, which has no k value. Oh, that should say which. It does not. I don't think it does still. So, which has no k value or doesn't contain a k value, something along those lines, has no k term. That I really can't write on this. There we go. Numbers aren't, oh well, they're bad, but they're not too bad. So independent as when we get that, we get 2/3 on 4, which has no k term. So that's part A. So now we're going to do something for part B, but remember now we're trying to get that it's going to have a basically divided by k in there. We're going to get a 1/k in there. So let's integrate that. So let's think about what we've got here. Let's actually write it out. So we have our limits of 2k and k, and we end up with 2x minus k squared. So we're going to have to consider what integration here that we could use. So what I'm going to do here is I think I'm just going to rewrite that in a way that makes my brain a little bit happier and something that I think is going to be more easy for my brain to integrate. I'm going to write that 2 a bit better as well. So that will be 2 lots of 2x minus k to the power of minus 2, and then it's just polynomials with powers, and I can do reverse chain rule on that now. I'm far happier with that. So let's think about that. So I'm going to say that I'm going to try f of x as, so let's deal with our bracket. So we're going to raise the power by 1 and then divide by it. So that divided by minus 1 is still minus 1. So that'll be 2x minus k to the power of minus 1. And then I'm going to check with chain rule that I get what I started with. So if I do that, we bring the power down to make it positive and then reduce it by 1. So that goes our 2x minus k to the power of minus 2, and then multiply that by the inside bracket differentiated, so that will give me a 2. So does that get me what I started with? I think so. I think that gets me what I started with. So, actually, does it? Yeah, it does. Yes. So I'm happy with that. So that is it integrated. So now let's just bung our limits into there. So I'm going to end up with, so we end up with minus, again I might shut the minus on the outside for now, just to make my brain a bit happier. So 2x minus k to the power of minus 1, can write it as a fraction if you wanted to, and that is with limits of 2k and k. So let's evaluate that with our limit. So I'm going to rewrite that as a fraction just because I know I want to end up with something in the form like 1 over k. So I'm going to make that 1 over 2x minus k. And then I need to put in, I've not put my limits in, have I? So then when I put my limits in there, so I'm going to end up with a 2x multiplied by, substituting in our 2k there. So that'll give us a 4k there in total. So that's 4k. And then we're going to take away when I put the second limit in. So that will just become 2k minus k. And then let's tidy that up a little bit. So that will become 1 over 3k minus 1 over k, like so. And then I'm just going to rewrite that as 3 over 3k, just so I can put that all together in terms of one fraction. So that will now become minus, and then it'll be minus 2 over 3k, and then because it's a minus minus, that whole thing will therefore become 2 over 3k. So that is inversely proportional to x, because it's in the form basically k, I was going to say k 1 over 1 over x, but a different term. So it is in that form because it's basically in the form a constant times by 1 over k. So let's just put our little explanation in there. So 2k Okay, again, I'm just going to put in as explicit as I possibly can be, just to make sure that I am extra clear about it. So make sure you do write a little explanation. Don't just stop there. Say why. Why is that inversely proportional to k? So it equals this. I'm going to put which is in the form. Oops, that again, writing. Writing. I'm not very good at it on this screen. 2/3 1/k, and that is inversely proportional, isn't it? Or proportional, I should say, to 1/k. So as long as you're showing there, it's proportional to 1/k because it's a constant multiplied by 1/k. And that is our answer.